Okay, so this is my RC10GTe. This is an electric conversion for the RC10GT. I made a video about this recently, the possibility of doing something like this. I'm not the first person who's done it. Different people have taken different approaches, and it basically comes down to, making a custom motor plate so you can mount an electric motor to the gearbox. Dynotech, the same company that makes those nice white Delrin suspension arms that I have on some of my other RC10s, they make a really nicely machined aluminum motor plate for the RC10GT, so you can do this. So that's kind of cool. So this particular chassis, I have two, also one right up there. I just finished this. I just mounted the electronics. I took it out for a test run in the driveway, and it actually drives really nice. Arguably better than my 10T that I would normally run for the Vintage Nationals, but I'm actually pretty seriously considering running this for the Vintage Nationals. Still needs a little bit of tuning, but it really drives nice. So I'll go over a little bit about what I did and some of the things that you should consider if you decide to do this kind of conversion on a GT. So as you can probably tell, I have a lot of RPM parts on this. The truck, when I got it, already came with several RPM parts: the RPM body mount, the RPM inner hinge pin mounts for the rear, RPM arms, and RPM ball cups. Those all came with the chassis. I also managed to find a set of RPM rear hub carriers, so that's pretty much every RPM part you can fit on this. Oh, plus the front bumper, I got that too. Let's see, the steering rack. There are a few different versions of the steering rack for the RC10GT. The one that I have on that truck right there actually has an integrated servo saver. And then the one that came with this was just a solid rack in the standard associated black plastic. This unit here is a GPM aluminum rack, and you have to fit two 4x8 bearings on each side of the bell crank, so four 4x8 bearings total. To mount it, and it's nice and smooth, seems to work great, no problems. So let's see, those are the main kind of peripheral components. Big bore shocks, as you can tell, front and rear. I had these on an SC10 that I no longer run, so I figured I might as well use them on this. And the settings I have for these shocks, I have both front and rear 3 down travel limiters, the 0.03 inch limiters, both front and rear. 2 by 1.6 millimeter pistons, front and rear. Rear oil is 30 weight, front oil is 35 weight. And for the mounting position, I'm mounting on the outside hole on the front arm, on the RPM arm, and the outside hole on the tower. And in the rear, I mount on the outside hole in the tower and on the inside hole in the rear arm. So the GT comes with this little extra sort of plastic piece here that you mount into the mounting holes you would normally use to mount the shocks. I presume this allows you to increase the droop on the suspension arm, and that's probably because the shock tower itself is very tall. I think it's taller than the 10T shock tower. So this likely compensates for that to get the same kind of droop back. The reason why I have to mount it on the inside hole in the bottom here, I actually have to do this because otherwise the big bore shocks will rub against the body if I mount on the outside hole. So I have to move to the inside hole here to get some clearance on the body. Okay, so those are the smaller details. The ride height, I set it to like 29 to 30 millimeters. It's just a base setting, 1 degree camber all around, just to, again, it's baseline setting, but it seems to work okay. Now, the tricky part here was the drivetrain. The really good thing about the RC10GT is that the gearbox is a 2.6 to 1 final drive ratio, which is exactly the same as the B4 and the T4 and the SC10, which also means that the differential is exactly the same part numbers, everything exactly the same. Now that's very convenient because then you don't have to go hunting around for vintage differential parts for a 10T, for example. So, you can really not have to worry about beating this up because it's easy to find parts. The idler gear that you use is for a standard RC10, but those are not difficult to find. And the input shaft, there is, you know, it has its own input shaft. Let me see if I can find that real quick. Sorry, just a second here. Can't remember where I put it. Oops, all right. I guess I'll have to do without it. I'll just pretend that this is the input shaft that I was using, which is not, but basically the input shaft that goes into this is like it would have in a normal RC10. It's about this size. This is actually a Hydro Drive input shaft, but it's basically the same thing. The tooth count on the GT input shaft is the same as for the B4, because again, it's the same final drive ratio. So that's great. And the B4 input shaft allows you to, it's longer out in this direction, so you can run a VTS slipper, which was what I wanted to do. And I also wanted to be able to more easily find different spur gears, because the VTS slipper or the B4 type slipper arrangement allows you to run a spur gear where the slipper patch is kind of notched into the spur gear. The older RC10s had a slipper unit where the slipper was one piece, and then you'd have to screw the spur gear onto the slipper unit. So those require a different kind of spur gear. So basically this whole thing is more compatible with my T4, which I also have these kinds of parts for. So that's great. There is a trick though, in order to mount the B4 input shaft into the GT chassis. You can't, it's not a simple plug and play. And the reason for that is because the part of the shaft that extends out this way in the short direction on the B4 input shaft is actually a little bit longer than it is on the GT input shaft. So if you were to just mount that into the gearbox, you would actually have, you wouldn't be able to close the gearbox. It would bind up, and so you wouldn't get free drivetrain movement. So what you have to do is just take a Dremel and just grind down the top part of that input shaft on this side to get it to be, you know, roughly the same length as what it is on the stock GT input shaft. So that's one of the really important things you have to do to make the B4 input shaft work. And then the other problem I had, even after I did that, I was still running into meshing issues between the input shaft and the idler gear. And the reason for that was because the teeth on the B4 input shaft, they were brand new. It's a brand new input shaft I'm running on this. And I guess they're just not worn in, or maybe the teeth were cut a little differently such that they're a little bit fatter. And so it doesn't mesh quite as nicely with the idler gear. So what I ended up doing is just finding an idler gear that I have that's a little more worn in, so that the it'll create a little bit more space between the idler teeth and the input shaft teeth from the B4. So I can get roughly the same mesh that I would have if I used a GT input shaft and a fresh idler gear. Okay, so hopefully, you know, the idler won't wear out anytime soon. I'm not running a lot of power through this. This is just a 17.5 motor, so, you know, it's nothing crazy. So it should be okay, but time will tell, of course. So that's what I had to do to, you know, deal with the drivetrain. One thing, actually, I'll get to that in a minute. Other drivetrain notes, you can get MIP RC10GTe CVDs. You can still find these on eBay occasionally, and they're the same exact CVDs as you would use on the RC10T and the GT2. They're same exact part. So if you wanted to use something newer like an SC10 or a T4 CVD, the dog bone's a little bit longer on those, and so you would need a rear hub carrier that's more offset towards the outside. And I simply don't know what you'd have to do there. I mean, I just haven't tried it, so I can't really say if you would need like a B4 hub carrier or maybe something different to get that to work with a newer type of universal, you know, a CVD or a CVA. So I'm just using the original GT type CVDs. Okay, so I think that covers it for the drivetrain. For the electronics, there are two ways to mount the electronics. So there's this method here, and let me just actually pull this guy up. This is my alternate chassis. So I first restored this one here that you see and then I did this one. And when I put this one together, I mounted the battery laterally along the width of the chassis. And that was at least the main idea I had, so that you'd fit the speed control maybe towards the right-hand side and the receiver in the middle there. And, you just route your wires and everything's fine. Now, the problem is with the D4 motor, the positioning of the motor mount screws are such that the wire tabs are off to the front here, because the motor mount screws don't go all the way around the can on the Trinity motors. It's kind of strange. So there's only like 5 or so motor mount screws. So basically, in order to mount this onto this motor plate, the wire tabs end up being way over on this side. So if I ran those the battery cups right up here along the width of the chassis, I wouldn't really be able to have space to route the wires onto these tabs. So I moved the battery over this way, ran it lengthwise, and put the electronics over here. That seems to work okay, but either way you do it, whether you run the battery this way or laterally, you may run into a problem with how many options you have for gearing. And the reason for that is if I want to run the battery lengthwise like this is a shorty pack. The battery itself runs almost right up against the servo mount. There's a little bit of space there, but not much, okay? And that's with the battery cup pushed almost completely out towards the motor plate. And the battery itself, because the chassis is in an angle here, the battery isn't straight like this. It's actually at an angle, so it can trace along the fold in the chassis here. So what that means is this corner of the battery plate basically touches the motor. So even though I have all of this space here to move the motor forward and backward, I can't really use it all because of the way this battery is mounted in this particular setup. So if I want to change my gearing, I'd have to change both the pinion and the spur at the same time so I can keep the motor in roughly the same position. I have a little bit of wiggle room here, but not much. So I can't just change the pinion. I have to change both of these. So that does limit my gearing options. Right now I'm running, I think, a 26 pinion and an 87 spur. And I have the stock static timing on this, which is 55 degrees. And I'm running 15 degrees of boost on the speed control. Boost is legal for Vintage Nationals, even though you use 17.5 motor with it. So that's perfectly okay. And I think I set the boost to kick in at 6,000 or 7,000 RPM. But anyway, I figured if I'm limited to this kind of option, then I might as well just run the pinion smaller, the spur bigger, and modulate my timing and boost to get the speed that I want. I had previously tried doing a 35 tooth pinion and a 78 tooth spur. That would have given me roughly the same gear ratio as like a 3569 on like a B5 gearbox, roughly, but not exactly. So, but the motor came off really hot, so I had to go to a much higher gear ratio. Anyway, enough of that. Basically, how you mount the battery will dictate how much of this motor mount space you can actually use if you want to change out your pinion without changing the spur. So that could be a problem. Maybe if you mount the motor laterally and push it forward a little bit, that would give you more space. Or if you want to basically try to mount the battery, right along the edge of the chassis, if there's a way, because the chassis bends, but the battery's flat, so you'd have to find a way to pick up the gap spacing that you'd eventually create by having the battery cup ride both the edge and the flat part of the chassis. But assuming you could do that, you could push the battery a little bit further forward and give you more slack. So that part, or you can mount the battery this way, but move it all the way to the front and move the electronics to the rear. That would give you more, wiggle room for the motor mesh, or moving the motor to get the right gear mesh with different pinions. But then you have a lot of weight that's forward. The battery is all the way forward. So that's a little tricky, but it's manageable. You change both the pinion and spur at the same time, you'll be okay. Yeah, I think that's it. So I covered the electronics, the parts, the shocks, the drivetrain. That should pretty much do it. I am really considering running this for the Vintage Nationals this year. It just drives so nice based on the couple of minutes that I, tested it out in the driveway. I have to do some more setup development work at my racetrack, but it drives awesome. I really recommend it. I had previously been getting my RC10T ready for the Vintage Nationals, and I put a Hydra drive on it because I really want to play around with that. But I'm thinking, you know, screw it, just run this. It's a simpler setup, easier to get parts. So we'll see what happens. But this is really cool. I really like it. So I hope you found this informative. Again, if you have, of course, any questions about this, let me know. I'd be happy to answer them. And thanks for watching.